Hello everyone, in today's lesson we are going to prove by induction that the summation of 1 divided by r into r plus 1 from r is equal to 1 up to n is always equal to n divided by n plus a 1. Now to do this, we are going to use a tape where T is for testing, A is for assumption, P is for proof, E is for explanation or a conclusion. Okay, so we are going to start with the testing for n is equal to a 1. So we are going to begin from the left hand side. So we are going to say that this is equal to the summation of 1 divided by r into r plus 1 from r is equal to 1. Don't forget that the value of n, we say that is equal to a 1. So this is equal to, we get a 1, we substitute where there is r. So we shall have 1 divided by 1 times, now 1 plus 1, we get a what? A 2. So we have 1 divided by 1 times 1 times 2, that is a half. Now we are going to test on the right hand side as well. So on the right hand side we have n divided by n plus a 1. So we substitute a 1 where there is n. So when we substitute a 1 here, we shall have 1 plus 1, that is a 2. And when we compare the left hand side to the right hand side, it is clear that a half is equal to a half. And when I see this happening, I'm going to say that the formula is valid for n is equal to 1. Now I'm going to test for n is equal to a 2. And on the left hand side, we have the summation of 1 divided by r into r plus 1 when r ranges from 1 up to a 2. So we are going to substitute. So when we substitute a 1, we shall have 1 divided by a 2. Then plus, when we substitute a 2 here, we shall have 1 into 2 into. Now when we substitute a 2 here, we are going to have a 3. So this simplifies to a half plus 1 out of a 6. And when we add a half onto a 1 out of 6, we shall get 2 out of a 3. This is left hand side. Now let's do the same on the right hand side. So on the right hand side, when I get this 2 and I substitute into my formula, we shall have a 2 divided by a 2 plus a 1. So this is 2 out of a 3. And when I compare the left hand side to the right hand side, it is clear that 2/3 is equal to 2/3. Therefore, we are going to say that the formula is valid for n is equal to a 2. Now, step number 2, we are going to assume that the formula is valid for n is equal to k. Remember, step number 1, we can test that it is valid for n is equal to 1, n is equal to 2, n is equal to 3. But it fails to be true for n is equal to, for example, 6, 7, and other values. Therefore, we have to first assume that this formula is going to be valid for n is equal to any number which is equal to k. So on the left hand side, we are going to have 1 out of 2. Remember, we are going to move from 1 up to k. So on the left, we shall have 1 out of 2. Then when we substitute a 2 here, we are going to have 1 out of 6. Then plus plus. Remember, we are moving from r is equal to 1 up to k. So this is 1 out of, where there is r, I substitute a k into a k plus 1, and everything is equal to, on the right, I'm going to have a k divided by a k plus 1. Step 2 is done. Now we are going to prove. What are we going to prove? We are going to prove that if this formula is valid for n is equal to k, comma, then it must be true. It must be true for n is equal to a k plus a 1. So we add one step onto the value of what? K. So we shall have a half, then plus 1 out of 6, then plus dot dot dot, then plus 1 out of a k into k plus a 1. Now when we add k plus 1, this ceases to be our last what? Step. So our last step is we get a k plus 1, we substitute into our formula where we see r. So this is 1 out of a k plus 1. We open up the brackets. Now I substitute a k plus 1 here. So when I do it, I'm going to have k plus 1, then plus 1. So this is a k plus 1 plus 1, that is a 2. So on the right hand side, I'm going to have a k plus 1, then divide by, when I substitute a k plus 1 here, we shall have a k plus a 2. So that is a k plus a 2. Now on the left hand side, it is clear that a half plus 1 out of 6 plus dot 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 plus 1 out of 6 k into k plus 1, we say that is the same as saying a k out of a k plus a 1. So where there is a half plus 1 out of 6 plus dot 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 plus 1 out of k into k plus 1, I'm going to substitute it with a k out of a k plus a 1, then plus 1 out of a k plus 1 into a k plus a 2. This is equal to the right hand side. So let's simplify the left hand side. Remember, we have it as a k out of a k plus 1, then plus 1 out of a k plus 1 into a k plus a 2. Now we need to find the LCM of k plus 1 and k plus 1 into k plus a 2. And this is automatically a k plus 1 into a k plus a 2. So k plus 1 into k plus 2 divided by k plus 1. So we get a k plus 2. So we shall have a k into a k plus a 2. Then plus, when we get k plus 1 into k plus 2, when we divide it with k plus 1 and k plus 2, we shall get a 1. 1 times 1, we get a 1. So this simplifies to k squared, then plus a 2k, then plus 1. Everything divided by a k plus 1, then a k plus a 2. But now the numerator, when we simplify it, we shall get k plus a 1 squared, everything divided by k plus 1 into a k plus 1. Now why are we saying that k squared plus 2k plus 1 is the same as k plus 1, everything squared? Now on the left, we have a perfect square, okay? So when we try to simplify this, we shall get k plus 1, close the brackets, everything squared. So this is the same as saying k plus 1 into k plus 1, then divided by a k plus 1 into a k plus 1. Sorry, k plus 2. So this k plus 1 will cancel with k plus 1. And finally, we shall have k plus 1, everything divided by a k plus 2. Remember, our right hand side, we had a k plus 1 divided by a k plus 2. And when we compare this left hand side to the right hand side, it is clear that they are equal. And if I see that this one is happening, then we are going to say, hence, the formula is valid for all integral values of n. Now, these 4 steps are relevant when you are writing your test item.